Welcome or welcome back to 3 Inquisitive Kids. In this video, we will be talking about angle bisectors, part 3 of lesson 3 of chapter 11. Here's our course outline for this unit. As you can see, we are already in our second to last video. In our next lesson, we're going to be concluding what we learned in one lesson called symmetric figures. Our learning goals for today is to understand and master the concept of angle bisectors through derivation, and be able to use the properties of angle bisectors to solve problems. So I want you to draw an angle on paper. Can you find its angle bisector? As you can see, this is our angle, and the line in the middle is the angle bisector. But how do you know for sure that this line is its angle bisector? As shown in the figure, AC is an angle bisector. AB equals AD, BC equals DC. Point A is the vertex of the angle. AB and AD are along the two sides of the angle. Can you prove why AC is the angle bisector? Well, SSS. Remember how we learned about the congruence of triangles? In this case, we're using the side rule. As you can see, triangles ADC and ABC are congruent because AD equals AB, DC equals CB, and they're all sharing side AC. So if they're congruent, then their angles would be equal. So these angles would be equal. Can we draw an angle bisector using geometry tools? So I want you to find out how you can draw an angle bisector using a ruler and a compass. A compass is one of those tools you use in geometry to draw a circle. We are given the angle AOB. Find the angle bisector of angle AOB. Here we have our angle, A, B, and O. You first use your compass to draw an arc here. So this point is M, and this point is N. And then you center your compass at point M, draw an arc, this arc, and then you also center it at point N. You draw an arc here. Where it intersects is point C. Then you can connect O with C to get OC. That's the angle bisector of angle AOB. Constructing angle bisectors is actually the most basic drawing technique you need to master from the compass, and everybody should practice and get really good with this. As you can see, both angles are equal. We are given straight angle AOB. Find the angle bisector of angle AOB. If it's a straight angle, you know that each of its bisected angles have to equal 90 degrees, which means all you have to do is draw a line perpendicular to angle AOB. So when you draw the angle bisector of a straight angle, all you have to do is draw its perpendicular line. OC is the angle bisector of angle AOB. Point B can be any point on race, OC. We know that PD is perpendicular to OA, and PE is perpendicular to OB. Measure the lengths of PD and PE and fill in the data in the following table. So we know that point P is any point on OC. You can choose a random point. Maybe the first point is here, second point is here, third point is here. And we know that no matter what, PD is perpendicular to OA, PE is perpendicular to OB. So no matter what. So now try to find the relationship between the length of PB and PE. No matter where you put your point P, you can still be able to answer this question. We can later find out that PD is always equal to PE. Now, how can you prove this? Any point on an angle bisector is the same distance from both sides of the angle. Given angle AOC equals angle BOC, point P is on OC, PD is perpendicular to OA at D, PE is perpendicular to OB at E. I want you to prove PD equals PE. I'll give you a hint. This has something to do with congruent triangles. So because PD is perpendicular to OA and PE is perpendicular to OB, therefore angle PDO and angle PEO are both 90 degrees. And in triangles PDO and PEO, angle PDO would equal angle PEO, angle AOC equals angle BOC, and OP equals OP. So now we know that these two triangles, PDO and PEO, are congruent because of the angle-angle side theorem, which means that PD is equal to PE because the triangles are the same. Knowledge point. A point on an angle bisector is the same distance from both sides of the angle. This is basically what we just talked about. These two lines are always the same distance. And when you say the same distance, that's the same thing as perpendicular. And if you want to apply this theorem to a problem, you first have to have 3 requirements. OC first has to be an angle bisector. The point that you're working with must be on the angle bisector. And you can't say, oh, P to, let's say, H is the same thing from P to E. Remember, it has to be perpendicular. Now I want you to prove PD equals PE. So OP is the angle bisector of angle AOB, and PD is perpendicular to OA, PE is perpendicular to OB, therefore PD equals PE. There are 3 requirements which must be written, which is what we just learned up here. As shown in the figure on the left, AD bisects angle BAC, which is given, therefore BD equals CD, and they are using the theorem we just learned. Is this right? BD equals CD. And then they are saying that they can use the theorem we just learned. But they are actually wrong, because this, as you can see, is not perpendicular to AB. For the second problem, they're also trying to use what we just learned, and they're saying that BD equals CD. But they are also wrong, because they are missing one of the 3 requirements. They never said that AD bisects angle BAC. Practice. In triangle ABC, AD is the angle bisector. BD equals CD. DE is perpendicular to AB at E. DF is perpendicular to AC at F. I want you to prove EB equals FC. Because we know that AD is the angle bisector of angle BAC and DE is perpendicular to AB and DF is perpendicular to AC, therefore DE equals DF, angle DEB equals angle DFC, which equals 90 degrees. In right triangle BDE and right triangle CDF, we have these 2 conclusions. Therefore, right triangle BDE is congruent to right triangle CDF using HL. That's a theorem we learned to find the congruence of triangles. Therefore, EB equals FC if they are fully congruent. As shown in the figure, AM is the angle bisector of angle BAC. Point P is on AM. PD is perpendicular to AB. PE is perpendicular to AC. PD equals 4 centimeters. Therefore, PE equals blank centimeters. PE is over here. We know that PD equals 4 centimeters. But how will we know that PD equals PE? And we can prove that PD is the same as PE, which means PE is also 4 centimeters. Here's a follow-up question. In right triangle ABC, AC equals BC. Angle C equals 90 degrees. AP bisects angle BAC and intersects BC at point P. PC equals 4, AB equals 14. The distance from point P to AB is blank. Point P to AB. It would mean this line. Remember, if we're talking about distance, we have to draw a perpendicular line. And this would equal 4. Why, do you ask? Well, they're actually trying to trick you. If you look, PD and PC are actually equal. If you extend AC a little bit and AB a little bit, you're left with an angle that is bisected. And AP is the angle bisector. So PD is also 4. Class summary. Today we learned about angle bisectors. We learned about how to draw it with a compass, its properties and theorems, which is the point on an angle bisector is the same distance from both sides of the angle. And we learned how to add auxiliary lines. You can draw perpendicular line segments from a point on the angle bisector to both sides of the angle in order to help you.